Exergen Corporation, in partnership with Industrial Global OEM Sales Division, Exergen Global. Infrared sensors have many benefits, like the ability to measure non-contact without touching, so you don't damage or contaminate your product. There are a variety of applications that range from anywhere in the food, printing, medical, and industrial markets. The various sensor configurations offered are based on what is required optically and environmentally. Ideally, your selection wants you to be able to measure a spot on your product that's at least 2/3 the size of your target or less. Smaller spot sizes minimize errors due to reflections and edge effects. Environmentally, it's important to keep your sensor clean and cool. Models with air purges are available to do such. It's also important to know the product's surface material, as each one has different emissive properties. For example, metals emit low and non-metals emit high. This video will help you over those hurdles to select the best IRTC for your application. To determine which sensor is best for your application, a few questions have to be answered. How large is your target? If your target is small, less than 0.3 inches, 8 millimeters, you have to go with something that has a small minimum spot size, like the IRTC 0.3x, 0.3SV, Micro IRTC, Focused Lensed IRTC, or Smart IRTC. If it's smaller than 0.8 inches, 2 centimeters, you can use either the IRTC 0.01, IRTC 0.03, IRTC 0.1x, IRTC 0.3x, Micro IRTC, Smart IRTC, or Focused model. If it's larger than 0.8 inches, 2 centimeters, select any of the sensors. How close can the sensor be mounted? Each model has a specific field of view. Field of view is defined as the ratio of the distance to spot size. For example, the IRTC 0.3x has a field view of 3:1 at a distance of 3x, has a spot size of 1x. At a distance of 12 inches, the spot size is 4 inches. At a distance of 1.5 meters, the spot size is 0.5 meters. The correct field of view would be determined based on the size of the target and how close you can mount. The spot size should be at least the size of the target, or, for best performance, much smaller than the target. For specialized optics, where a slot spot or small spot is required at a distance where a standard model won't work, we have adjustable IRTCs with close, medium, long, and extra long focal lengths. What is the ambient temperature where the sensor is to be placed? If ambient is less than 160 degrees Fahrenheit or 70 degrees Celsius, choose any sensor. If the ambient is less than 212 degrees Fahrenheit, 100 degrees Celsius, choose any sensor except the IRTC 0.01, the IRTC 0.03, or the IRTC 0.07. If the ambient is greater than 212 degrees Fahrenheit, 100 degrees Celsius, we have units with built-in air cooling to 400 degrees Fahrenheit, 204 degrees Celsius, and cooling jackets to cool to 700 degrees Fahrenheit, 371 degrees Celsius with air, and 1000 degrees Fahrenheit, 537 degrees Celsius with water. What is your target temperature? We have pre-calibrated IRTCs that are calibrated to match the output of conventional TCs at temperatures close to their calibration points, and will be linear within 2% in that range. If you have a narrow temperature range between 0 and 500 degrees Fahrenheit, -18 to 260 degrees Celsius, select the pre-calibrated model based on this chart. If you have a wider temperature range, go with the linearized Smart IRTCs. Ranges from -30 to 70 degrees Celsius, -22 to 158 degrees Fahrenheit, 0 to 100 degrees Celsius, 32 to 212 degrees Fahrenheit, 0 to 250 degrees Celsius, 32 to 482 degrees Fahrenheit, 0 to 500 degrees Celsius, 32 to 932 degrees Fahrenheit, and 0 to 1000 degrees Celsius, 32 to 1832 degrees Fahrenheit are available. If you have a narrower range that needs to be specifically calibrated or is higher than 500 degrees Fahrenheit, go with the adjustable IRTC. and for the OEMs, special optimized calibrations can be obtained. What is the target material? The pre-calibrated IRTCs and smart IRTCs are designed to measure only non-metals and coated metal surfaces. If the surface is metallic, an adjustable IRTC with a low E filter will work, only for temperatures more than 500 degrees Fahrenheit. And thin films are also difficult to measure without special filters. Is there dust, debris, moisture, or condensation in the air? The IRTC 0.3x, IRTC 0.3SV, IRTC 0.5, IRTC 0.10, Micro IRTC 0.4SV, Smart IRTCs, and adjustable IRTCs all have built-in air purge for keeping the lens of the sensor clean and dry. It is recommended to use air purging for that reason. There are also air purge jackets available for some models. Choosing a temperature controller input device. The most important thing is to select a controller input device that has leakage current less than 1 nanoamp, or has enough offset to calibrate out the error due to leakage current. If the leakage current is less than 1 nanoamp, no offset is required. Since the self-powered IRTCs emulate thermocouples, any TC input device with leakage current less than 1 nanoamp will work. Each IRTC model is specifically designed for optimum performance in the region of best linear fit with conventional TCs, but can be used outside of this range by simply calibrating the readout device appropriately. The output signal is smooth and continuous over its entire rated temperature range and maintains 0.01 degrees Celsius repeatedly over its entire range. Some input devices are programmable and can accept custom millivolt signal output tables or polynomials. Exergen can provide those tables to expand the linear range. If your input device only accepts analog output, such as 4 to 20 milliamps, 0 to 5 volts, 0 to 10 volts, or RS-232 output, we have inline transmitters that can be wired to the self-powered IRTCs or self-contained smart IRTCs that have linear analog output.